In this video, I'm going to show you how to create a circle graph, or what's known as a pie chart. I know that you've looked at pie charts in your life before, but creating one is just a little bit tricky because we have to come up with the number of degrees that each category represents in the circle. Again, this is great for qualitative data, non-numerical data, data that fits into a category, such as what math class are you currently taking? Algebra, 8 students, geometry, 5 students, calculus, 5 students, statistics, 2 students. So when we ask these 20 students what class they were in, these are our results. And that's your first step, is to get a tally for each category. Your second step is to then determine a fraction. For example, algebra represented 8 of the 20 students. Geometry represented 5 of the 20 students. Calculus represented 5 of the 20 students, and statistics was 2 of the 20 students. Each of those fractions can be reduced. 4 goes into both of these numbers, 2 and 5 times respectively. Geometry, 5 goes into each of those numbers, so 1 and 4. Same for calculus. And for statistics, 2 goes into both of those numbers, so 1 and 10. From here, our third step is to turn each of these fractions into a percentage. So 2/5 is 0.4 or 40%. 1/4 is 0.25 or 25%. Same for this one. And 1/10 is 0.1 or 10%. So those are the percentages of the circle that each one of these categories should represent. So when we're making our circle graph or our pie chart, there are 360 degrees. 25% of 360 degrees is 90. You can get that by multiplying 0.25 by 360. So there's going to represent 90 degrees. Geometry also represents 90 degrees, so I'll just do another one of those, quarter of the circles. 10% of 360 you can get by doing 0.1 times 360, which is 36 degrees. Now 36 degrees you can either use a protractor or just try to eyeball it and make it close. If I came straight across, that would create another 90, and if I cut that in half, that'd be 45. 45 is too much as I'm only looking for 36, so I'm just going to come in a little bit from there. That smaller wedge here would represent the statistics. And then finally, over here, in the final largest chunk of the circle graph would be the algebra students. It represents 40% or 144 degrees of the available 360 in a circle. You need a title, and this would be current math class. And oftentimes you can include the percentage, 25, 25, 40, and 10. It's also good sometimes to create a legend or a key to help organize your work. So we'd have algebra, we'd have geometry, we'd have calculus, and we would have statistics. And what we could do is we could use various colors to help us represent those. We could make, say, blue for algebra. We could do, say, red for geometry. Oops, excuse me. Geometry was 25%. We could do, say, green for calculus. And finally, we could do, say, black for statistics. And now you've got a circle graph where each wedge of the circle represents the amount of degrees as a percentage, and therefore visually it shows you the largest area was the one with the most responses, and the smallest area was the one with the least number. So visually it gives a very similar look as a bar graph, just in a circle graph presentation.